All right, Block Physics people, this is a review of Monday, Tuesday, 9/21, 22. For some reason, our slide's a little bit messed up. But just wanted to tell you what we did today if you missed, or also a preview for Wednesday. So some of you guys will be watching this on Wednesday because we didn't get to this part of the presentation. Remember, Speed 1 and Speed 2 are due at the end of the day, Tuesday, 9/22. If you have a problem, you had just some issues, always contact me. We'll make sure that you get your credit, and we'll talk about what went wrong. But right now, let's see if we can get everything done by the end of the day, Tuesday. All right. So that's just that. I'm not going to spend any time on this. I'm going to go straight to our metric system. So first thing is, why do we learn the metric system? The metric system is an important tool in science. Okay, why? Well, because when we measure things, we need to be accurate. And the metric system allows some accuracy and some ability to move things around that's easier than the US system. So in length, when we do lengths, we're going to measure in meters. When we do time, we're going to do it in seconds. Remember that matter is always either a solid, a liquid, or a gas. Mass will measure in kilograms and volume in liters. So if you're going to be taking notes or anything like that, you can pause the video right now and say, these are important things that you're going to want to know. Length in meters, time in seconds, mass in kilograms or grams, and volume in liters. We'll talk about why mass is a little bit different later. All right, why the metric system? Well, the US system is kind of weird. You can have a foot, right? And a foot is a big part of what we learn on how to measure things with the ruler. But for some reason, there's 12 inches inside a foot. And so why 12? Just happened because of history. And inside every inch, though, there's 8 markings. So there's 8 markings inside of an inch, there's 12 inches in a foot, and there's 3 feet in a yard. Okay, comes right off of my tongue because I know it and I've lived it, but it doesn't make a lot of sense. So the metric system is a lot easier in that there are 10 millimeters in every 1 centimeter. There's 10 centimeters in every 1 decimeter, and there's 10 decimeters in every 1 meter. And so there's no 12, 3, 8, right? It's just, that's how it goes, right? 193 countries in the world use the metric system. We're not one of them. If you're in my class, you would hear why I think that's still a very good thing. The US system continues to be the driving force of how we buy gasoline and how we measure our weight and things like that. And there's nothing to be ashamed of it. This is how we operate, and this is how the people in this country are accustomed, and we do very well with it, so there's no reason to change it. But we do have to learn the metric system because everybody else is using it, and we're going to use it inside our science. All right, now the metric system is made up of bases. So we just looked at those bases. Bases are the meter, the gram, the liter. So it's the base unit, the first unit. And then everything on top of that or before that is our prefixes. That tells us how many to multiply that base by. So kilogram, kilogram, would be 1,000 times 1 gram. Whereas a centigram would be 1/100th of a gram. All right, we're going to learn how to do that. There's no need to memorize that at all. But we just know that that's how the system works. All right, nothing to write down here, sorry. Just wanted to show you that the base units for the different things we measure, length, mass, time, and liters are here, and there's more of them as well. So we have for electricity, ampere, Kelvin, the mole, something you'll learn about next year in chemistry. No need to memorize any of this stuff. We will definitely give you a way to do it. You're going to see it right now. All right. So this is a really tough slide to look at. This is the metric system, and the metric system is quite handy once you learn how to use it. And so for the next 5 minutes, we're just going to teach you how to use this chart. There'll be no memorizing. There'll be no test to ask you how many kilograms are in, or grams are in a kilogram. Okay, that's not what we do in physics. We're going to show you how to go about using this chart, and the way this chart is set up will help you do that. That's what you'll need to learn. How is this chart set up? And so if you look here in the middle, there's the base unit. This is where things like meter go, gram, and liter. That's the base unit. And so if we wanted to know what a kilogram is, well, it would be 1,000 grams. And if we wanted to know what a milligram is, well, we would know it's 1/1000th of a gram. And so you can say to me right away, you say, Mr. Block, you promised me we wouldn't have to memorize. And I'm going to tell you exactly the reason why. Okay, so I'm going to turn the doc cam on for a second. And you see we have our yellow sheet here, and under the doc cam is our reference sheet. We're going to be finding all of our equations. All right, some hints about some geometry and trig issues. Here we have a list of all of our variables that we use, but on the back, here is our metric system, okay, and our conversion factors and some other things right here. So here is that same chart without everything to the left of it. And so the question becomes for you, well, I thought we didn't have to memorize it. You don't have to memorize it. You just need to know how it operates or how it works, and you can recreate it in just a matter of seconds. What do I mean by that? Well, the way that we look at this chart is we look at the middle part of it like that. Okay, between milli and kilo, this is the middle part. All right, and so what we're going to see when I turn back on the presentation is that that middle part is pretty easily recreated. If we go up from the base, we go to 10, and then we go up to 100, and then we go up to 1,000. You see we're adding 1 0 at a time. If we go down to 10, down to 1/100th, down to 1/1000. We add 1 0 all the time. And so when you look at your yellow sheet, you're going to kind of say, okay, I know that here's the base right here, and that deca is 10, and hecto is 100, and kilo is 1,000. And I'm going to know that deci is 1/10, and centi is 1/100th, and milli is 1/1000. All right, so I know that, and it's very simple to remember that. I'm just going to remember between these two spots, we go up a 0 or we go down a 0. Okay. Now, after this middle section, then things are going to be a little bit different, but not much. So when we look at that, we say, all right, once we get past kilo and we go to mega, now we're adding 3 zeros at a time. So we go from 1,000 to 1 million. And then from between mega and giga, we go from 1 million to 1 billion. And then we go up to 1 trillion. So you see how we add 3 zeros after that middle section. And the same thing is true on the bottom side. After we go down to 1,000, then after that, we're going to add 3 zeros. So micro is going to be 1/1,000,000th, and nano is going to be 1/1,000,000,000th. So again, don't worry about memorizing, and don't even worry about when I say 1/1,000,000,000th or 1 or trillion. Right? That's not what we're going to be. We're going to be focusing on these numbers here. And so as long as you know that we go up a 0 up to kilo, and then we go up 3 zeros after that, or we go down 1 0 down to milli, and then we go 3 zeros down after that, you're going to be fine. Now, are we using the metric system already? And the truth is you guys are. You may not even know it. So when we buy our phones, or when we used to buy computers when they were first coming out, we were really happy when they had about a couple hundred megs of data storage. We were really happy. But the scientists keep pressing the envelope, making things faster and faster and faster. And so now what used to be a PC with a couple megs now has a terabyte of data in it. In your phones, remember, you guys all want a phone that has at least 32 gigs in it, or probably 64, and a lot of you maybe even have 128, okay? Gigs, so gigabytes of data. That means you have 128 gigs, or 1 billion bytes of data storage. All right, so let's take a look real quick. How are we going to use this to our advantage? So I'll go through this real quick. This is the most important part. Yes, okay. So right here, we need to learn this very simple step of trying to come up with metric values to equate things like the kilometer to the meter or the milliliter to the liter. And so we're going to practice this skill. We're going to practice it many, many times. But this is the first time I'm going to introduce it. Because we want to make things easier for you, we're going to do a two-step process. You're no longer going to have to remember all those numbers. You're just going to have to look at your yellow sheet, and hopefully that will tell you the number. And if you do what we're talking about here, you're going to be able to do what we're going to do next week, conversions, very easily. So what am I talking about? Well, if I want to find out how many meters are in a kilometer, right, I have to do two things. So put the camera back on real quick. If I want to know how many kilometers or how many meters are in a kilometer, the first thing I have to do is ask myself, which one is bigger? Which of these two units is bigger? Now you may know it already because, right, I can walk, like step almost a meter, but I have to walk a couple, maybe 10 minutes or 6 to 8 minutes to walk a kilometer. All right, so how do we know that this one is bigger just from life, but what if we don't know? What if we like say, I have no idea? Well, that's where you can use your yellow sheet. What we need to know is that for a meter, right, meter is the base, it's right here, and kilo is here. And what we saw in that chart is that as we go up the chart, everything gets bigger. So anything that's highest on this chart is the bigger of the two. So if meter is here and kilo is here, then kilometer is the biggest of the two. And so what we do in our process is we say, all right, we put a 1 in front of that bigger item. And now we look at our chart and we say, okay, what is the number for kilo? Well, I don't know. I didn't memorize it. Ms. Block told me not to. But I know that there's the base, and I know that this is 10, and this is 100, and this is 1,000. Kilo is 1,000. And so this number is 1,000. Okay? And that's how we do that quick conversion, or that's how we create those. So let's write down these next ones. Milliliter, I'm going to pause it real quick. I'm going to put all of these up, and we're going to do them real quick on this video. Okay, so now I just took the chart from the presentation and put it on a piece of paper, and we're going to do all of these real quick. All right. So what we do is we say to ourselves, all right, first, if we want to find out how many milliliters are in a liter, we ask ourselves which one's bigger. Well, which one's bigger? Well, milli is down here, liter is the base, the liter is the highest one of the two, so liter is the one that gets the 1. And then we go to our chart and we say, okay, what's our number for milli? Well, this is 1/10, this is 1/100th, this is 1/1000th. And what you need to remember is that because we're putting ones in front of the bigger ones, we no longer need to worry about whether or not it's 1/10 or 10. Right? We just have to put in the number. So for deci, it would be 1/10, we put 10. So since milli is 1/1000th, we just put in 1,000. Right? So there are 1,000 milliliters in every liter. All right, centigrams to grams. Which one's bigger? Well, if I look at my chart, the base is higher above centi. So that gets the 1. And centi is down 1, 2. So 10, 1/100th. So 100. And now we have a good check in our system here, because we know from moving around with the limited stuff that we do with the metric system, that there are 100 centimeters in every 1 meter. We know that. And so we know that now there's 100 centigrams in every 1 gram. All right? All right, last couple seconds to microseconds. Well, micro is way down on the list here. It's all the way down here. And so I'm going to put a 1 in front of the bigger one, seconds. And I'm going to go down to micro, and I'm going to say, okay, 1/10, 1/100th, 1/1000th. And I'm going to make sure that I don't say 1/10,000th, right? Because it's not. It's, remember, after the first 3 steps, we start adding a 0. So micro, right here, this small u would be 1 million. And we add 3 zeros after that. All right. Meter to megameter, mega way up here. A meg is way up here. And so the meg is the bigger one. That gets the 1. And how many? Well, 10, 100, 1,000. And we go up to 1 million. Remember, we had the 3. So 1 million meters in a megameter. And last one, hectoliter, which is hecto right here, and a liter. So hecto is bigger. That gets our 1, and our number 10, 100. So 100. All right, those are our conversions. Those are how we go about do that. If you don't understand that right now, or you think, oh my God, I'm going to forget that, we will get many, many, many more chances to practice that. All right. Last thing before I close off this video is we need to learn a little bit about measuring. So we're going to go through all this. Measuring. Length is measured with a ruler. Mass is measured with a balance. Okay, we can talk about volume in chemistry, but it's either by measuring length, width, and height, or we use a graduated cylinder. All right. So when we make accurate measurements, we have to be careful about how good our measuring device is. So when we do this in class, I say to the kids, how long is this? Some people say 3 centimeters, some people say 4, right? But then when I say, well, what if I got a better ruler? Well, now you could say, oh, well, now I know for sure it's like 3.5, or maybe 3.6, 3.7, right? What if I got even a better ruler and I got all these spots in it? Well, now I can know even better, right? Now I know for sure it's like 3.7. And so that's why we have to be careful when we put a bunch of numbers down, when we measure stuff, that we put our start at the 0, and then we put our tip at the end here, and we measure down, and we make sure that we put in all of the values that we have. So this one would be 3 centimeters, and then it would be 0.7, 3.7 centimeters, and we always put in the units. All right, so read big to small. What is the smallest placeholder? Include units. So in this instance, right, the smallest placeholder is the millimeters or the decimal 0.7. All right, and now if we're going to skip through all this, if we want to do measuring mass with the triple beam balance, remember we're going to put our item right here. We're then going to move these weights back and forth to try to get this to balance right in the middle of this section. So if it's too high, we got to go back. If it's too low, we got to move forward. You guys will get a chance to do it, but we're just going to practice reading right now. And so if we want to read a triple beam balance, what we do is we just start with the big number 100, then add the next number 20, then add the last one, which is 4.9. So this would be 124.9. All right. This next one right here, you see like the big number here, 300. So 310. And you see we don't even get to the 1. So it's not 311. It's going to be 310.9. So I'm going to close off right there. If you're watching this video, you're probably watching it for the second time, so good for you. Remember to do the Go Formative, which is just a couple of things on the notes from this, and I'll see you guys on Thursday.